Saving and loading. There are many ways to save and load data in iOS application. This chapter will take you through some of the most common mechanisms, as well as the concepts you need for writing to or reading from the file system in iOS. Along the way, you will be updating Home Corner so that its data persists between writes. Before you start, you need to adopt a singleton pattern for the data. You can understand that only one piece of data is used globally. Open itemstore.swift and add the following code. It means that when itemstore.sg instance has not been initialized, an instance will be created and initialized. Otherwise, itemstore.sg instance that has been created will be returned directly. You will implement the load changes method later and use it to load data from the local file system. You can temporarily ignore the error prompts it causes. Then you can use the item store share instance wherever you need to use it without creating it separately. Now change all item store in your code to itemstore.shared instance. Build and run the application. If all the code has been modified to the correct, it will succeed. Archiving. In Home Corner, the model objects that a user manipulates are instances of item. For Home Corner to be a useful application, instances of item must persist between runs of the application. Classes whose instances need to be archived and unarchived must conform to the NS secure coding protocol and implement its two required methods, encode and init. Now, open item.swift and re-implement your item class like this. NS secure coding, inherited from NS coding, is a protocol that enables encoding and decoding in a manner that is robust against object substitution attacks. In order to store data in documents directory, we must use NS secure coding instead of NS coding. In addition, NS secure coding must override the getter for its support secure coding property to return true. In item.swift, implement encode to add the names and values of the item's properties to the string. The purpose of the key is to retrieve the encoded value when this item is loaded from the file system later. Objects being loaded from an archive are sent the message init. Notice that this method has an NSCoder argument too. In init method, the NSCoder is full of data to be consumed by the item being initialized. Also notice that you call decode object on the container to get objects and decode integer to get the value in dollars. Application Sandbox. An application sandbox is a directory on the file system that is barricaded from the rest of the file system. Your application must stay in its sandbox, and no other application can access its sandbox. The application sandbox contains a number of directories, documents, library caches, library preferences, and temp. The instances of items from Home Corner will be saved to a single file in the Documents directory. Implement a new property in itemstore.swift to store this URL. In itemstore.swift, implement the save changes and load changes method. NSKid archiver is an encoder that stores an object's data to an archive referenced by keys. And NSKid unarchiver is a decoder that restores data from an archive referenced by keys. It's a little difficult to fully understand these two classes. You can refer to the developer documentation for more details. When the user pressed home button on the device, the message application did enter background is sent to the application delegate. That is when you want to send save changes to the item store. At the same time, application will terminate can ensure that the data can be saved when the application terminates. Make sure load changes is called when initializing the item store shared instance, and do not create any item in init method. Build and run your application and check whether the data is saved when you reopen it. Let's delete some existing items. Double-click the home button on the device, terminate your app, and then reopen it. As you see, the data is saved when you reopen it. Writing to the file system with data. Your archiving in HomePoner saves and loads the item key for each item. But what about the images? At the moment, they are lost when the app enters the background state. In this section, you will extend the image store to save images as they are added, and fetch them as they are needed. In order to simplify the work, you need to design the image store as a singleton mode, just like you did with item store before. And make sure all places that use image store access it through image store.shared instance. The images for item instances should also be stored in the documents directory. Build and run the application. Make sure everything is OK. You can use the image key generated when the user takes a picture to name the image in the file system. To save and load the image, you are going to update the setImage and image methods. The setImage method saves the image file in both cache and file system. The image file will be saved in PNG format with its key as the file name. The image method will first try to get the image from the cache by the key. If the getNew, reload the image from the file system and set it back to the cache. This is a very efficient caching mechanism in practice. Here you can see the files you saved. Let's try it on the Kermit saved item. You will see two pictures saved in the file system. Error handling. In setting image method of image store, you use the doCatch statement. Swift provides a rich error handling system with compiler support to ensure that you recognize when something bad could happen. You already saw this when the Swift compiler told you that you were not handling a possible error when writing the file to disk. If a method could generate an error, its method signature needs to indicate this using the throw keyword. With option clicking on write, you can see the method definition for write. The throw keyword indicates that this method could throw an error. If you are familiar with throwing exception in other languages, Swift's error handling is not the same as throwing exception. To call a method that can throw, you use a doCatch statement. Within the do block, you allocate any method that might throw an error using the try keyword to reinforce the idea that the call might fail. If a method does throw an error, then the program immediately exits the do block. No further code in the do block is executed. At that point, the error is passed to the catch block for it to be handled in some way. Within the catch block, you can optionally give this constant an explicit name, for example, catch let error. There is a lot more that you can do with error handling, but this is the basic knowledge that you need for now. We will cover more details as you progress through this course. Congratulations! You built your first persistent storage program. See you next time.